Hi, I'm Milan Gandhi. We have developed a airfare delay analysis tool, and this is the executable. We'll click open. It'll take a couple of seconds to activate. So this is the airfare delay analysis tool, which consists of two applications: airfare analysis and delay analysis. What this airfare analysis application does is it analyzes the number of flights, that's the frequency required to fly a particular route on a daily basis, with which aircraft size and airfare that would be profitable to the airline. And the second application is delay analysis. This application will allow us to calculate the total gate, taxi and air delay cost, and which aircraft size has the greatest gate, taxi and air delay cost. So first let's have a look at the airfare analysis application. Let's start. So this is in the kept on our developers mode, where we need not put the input data. This is basically done by the developers who keep on testing the application till it gets the final results. So we just have to click on the new row, and all the input fields which are required will be automatically populated. Then we'll click on the generate button and a report will be generated. We'll save that report and analyze the whole application. So first let's click on the new row. So this is the data already been input. So here we can see is the market, that is origin and destination, that is New York to Orlando market. The airline is trying to analyze this particular application for its what airfare should be provided to the passengers and what aircraft size should be availed to this particular route. So this market is there. These are the seats that consist of the aircraft size. So 75 size, 50, 100 seater, 125 seater, and so on and so forth till 325 seater. So different size of aircraft are here. The burn rate, that is a airborne fuel burn rate, which is applicable when aircraft is flying, is input. And the direct operating cost, that's a crew cost and maintenance cost and so on and so forth, ownership cost, all are direct operating costs which are entered by the airlines. And the fuel price is taken as $2 per gallon throughout this particular all the aircraft sizes. And the landing fees, when it lands at Orlando, what are the landing fees which are mentioned here? They're all in dollars. And the hours, the number of hours flown are required to fly from New York to Orlando is here. And they are also in hours, that is 2.5 hours and 2 hours 48 minutes and 2 hours 2 hours 67 seconds, 67 minutes, and so on and so forth. So this is the input to be done by the airlines. Now we will keep click on the generate button. A report will be generated in Excel. We'll name this file as airfare. We are analyzing the airfare, what airfare should be there for a particular aircraft type to fly for a day on a daily frequency basis. Airfare, okay, and we're going to save it. We're going to save it at this particular folder from where we started this application, the executable, which we clicked. And this is where we'll just go and see report must have been generated. Yeah, so airfare.excel file is generated. We'll open this report. The report would consist of the input fields which we saw earlier, and the output field. So this is the report generated. These are the input fields which we saw here, which was automatically populated, all these fields, and the output has been generated in the form of Excel file with this particular thing. So we will be evaluating different sort of the airline is evaluating, in fact, like if they fly 10 flights per day for a particular number of seats, that's a particular type of aircraft, say consisting of 100-seater, then what would be the airfare? Should be made available to the passengers, and what would be the cost, what would be the revenue, and what would be the profit. So based on this input data, we are getting this particular output. So there are we will take a scenario where there are 10 flights per day, which is a daily frequency. This particular airline will fly this particular market with this particular aircraft size to understand which gives them the which is most profitable from the airfare point of view and from the aircraft size point of view. So the 10 flights will take a scenario, then we'll take a scenario of 3 flights per day, then there is 2 flights per day, 2 flights per day, then there is go below, we will have 5 flights per day and 20 flights per day. So first, looking at it, we will see how the calculation works. These are the 10 flights. First, we saw this aircraft size. These are the aircraft size can be used available to the airline to fly this particular route. So based on that, the load factor is assumed to be an 80%. So if you look at it, 100 is a 100-seater aircraft is there. So the load factor, the occupancy of this particular aircraft for the passengers is 80 passengers are going to be flying. So this is the load factor at 80% we have taken. So any aircraft which is going to be flying with the aircraft size will be having 80% of the load factor. That's 80% of the occupancy. Then there is the burn rate, the airborne fuel burn rate is input. Then there is a direct operating cost as mentioned, and fuel price, landing fees, and the hours which will be the flight will be in air. So so this is the input fields which we saw earlier. Now we'll see how the calculation is done. This is demand. Basically 10 flights are there, and let's take a scenario where there are say this particular scenario, it's a 200 aircraft, a 200 seat aircraft which is flying. It will have an occupancy of 160 because the load factor is 80%. So the 40 seats are deducted, so 180 passengers are flying, and with all this burn rate in this and all the other input fields, what number of passengers actually are flying is 1600 passengers can fly. 10 flights into 160, so that is 1600 passengers can fly this. Now we'll look into how this particular basically how it's calculated. This is the demand basically of 1600. So demand is equal to number of flights. This is number of flight times aircraft size. Aircraft size is this. We are taking aircraft size of 200, and the load factor. And the load factor is 160. So 80%. I mean to say. So it gets to 150. We are getting the total demand of 1600 passengers. Now the second this calculated column is the airfare. How do you calculate the airfare? And airfare is calculated by revenue divided by demand. Okay, so revenue is here. So we'll look at this particular revenue, and this is divided by the demand, that is 1600 passengers. Now we'll see at the cost. What's the cost of flying this particular aircraft with the number of passengers, with the number of flights taken into consideration. 10 flights will be taken per day of the daily frequency. What's the cost? So cost is equal to number of flights into landing fees plus the hours, number of hours flown, and into direct operating cost. This is the direct operating plus the burn rate, and into the fuel price. So this would be so we'll get this particular cost. So here is the cost. See, the cost is 976,415. So that would be the cost. Now we'll look at the revenue. How is revenue calculated? The demand into demand minus the market size. There is a market size parameter which the airline would be having, and that is divided by the coefficient, and that would give us the revenue. So this particular revenue is 2,319,829. So the revenue is this much, the cost is this much, the airfare is 145 almost dollars. And what is the profit? Profit is here after deducting revenue minus cost is 1,343,414. So this is the profit generated of flying a particular aircraft on a daily basis, or 10 flights per day. The frequency is 10 flights per day. The airline would generate a profit of 1 million, and so and so. So this is taking in assumption if the airline is flying 10 flights per day. Similarly, the 3 flights per day, what would be? And so if you look at all the profit columns out profit in this profit column, if you look, if you check all the values, this is what we choose was this one with the 1600 with the aircraft size of 200 is the most profitable for the airline if they are going to fly 10 flights per day in comparison with other aircraft types. So 200 seater aircraft type seater is the most profitable for the airline, which gives them the airfare calculations of $145, and that gives them the total profit. If you look at the profit column, this is the highest what we choose right now. So this way the 10 flights can be analyzed with a different aircraft size. Similarly with the 3 flights per day, this is 3 flights per day, you can analyze the same way. And here if you look at it, in 3 flights per day profit, here this is the highest, that is 140,113. So this is, if you look at all the columns, the profit generated by this particular aircraft size. Let's see the aircraft size. Aircraft size is 75 seater. 75 seater gives them the most profitable, airline gets the most profitable, is most profitable to them. If you look at if you look at the calculations via the airfare, so the airfare cost and revenue, you getting this, and what airfare is there is 151.5, that's $152. This would be the maximum the airline would be generating a profit if they are going to fly 3 flights per day with a 75 seater aircraft. Similarly for 2 flights, and it will carry how much passengers is 180 passengers. The simple calculation is 75 seater into 3 flights is 225, plus, then we got to deduct 20%, that is 80% load factor, and we're getting 180 passengers that would be flying. Realistically, this is not the option airline would go. And then the same way, the 2 flights, if you look at this 2 flight profit column, this one is the highest, that is 154,228, which would have again, if you look which kind of aircraft they would be choosing is 75 seater. Yeah, so 75 seater will be applicable for this profitability, and which will be having the airfare of here is the airfare is $202. So this way, if 2 flights on a daily basis, on a frequency of 2 flights are flown for this particular market from New York to Orlando, so this particular profit is generated for the airline using the aircraft size of 75. Now we'll look at the more realistic values, because if you're going to fly 2 or 3 aircrafts, it's not going to be working based on the demand also, and that from the profitability point of view. So now we're looking at 5 flights per day. So if you look at in this profit column, 5 flights is the highest, 175,814 is the highest profitability of using any other aircraft. So which aircraft size is being used? So here the total is 800. 800 is means if they are flying 5 flights per day of 200 seater. If you go over top, you'll see the 200 seater here, and that is here 800. So it deducts 1,000 passengers. Is the capacity of the aircraft. With a 200 seater, 5 times it's flying 1,000. With we deducted the load factor. This 800, 200 is deducted, so 800. So what was the airfare is $208, and what's the cost is 488,207. And what is the revenue? Revenue is 1 million, and what's the profitability? 1,664, and what's the final this thing is 1 million. 1 million is the 1,175,814 is the profitability. So this is the way 5 flights are profitable if they are flying 5 flights. Now if they are flying 20 flights per day, let's have a look at the profit. So it's 20 fly has got the profitability of 1,169,386. And which type of aircraft they're going to fly is the third row. So we go to the third row on top. This is the one, 75 seater. It will be having 20 flights per day. The profitability will be 1,169,000. The what would be the average fare? Average fare would be the $171 per the airfare and one way. And then what is the cost is 884,000 and so and so. And what is the revenue? Revenue is 2 million 53,708 600. So this is the profit generated for flying 20 flights per day with a 75-seater aircraft. So in all, if you look at it, the most profitable, if you of all this daily frequencies of number of flights, that's 10 flights or 3 flights or 2 flights, 5 flights per day, or 20 flights per day, is the 10 flights per day is the most profitable for the airline, having profit of having a profit of 1 million profit of 1,343,414. So airline would go for this particular 10 flights per day frequency with the capacity aircraft size of 200 carrying 1,600 passengers, with as the load factor deducts 25% of the 2,000 passengers can fly the capacity. So 1,600 with the average airfare of $145, and it will be having this much cost, 976,415 cost. The revenue would be 2,319,829, and the profit will be 1,343,414. So this is the way the application is there, this developed, and as you can see, from all the profitability, 1 million, this one 169,000 for 20 flights is less than this particular 10 number of flights flying. 20 flights per day for the 75-seater is less, and the same time 1,175,814 for 5 flights per day for the 200-seater is less than this particular figure of flying 200 seater aircraft with a with the airfare of 145, carrying 1,600 passengers. So airline would choose to go for this particular airfare. So this airfare analysis can be done for the airlines in this way. So this is the application. Now we'll go back to the other application. We'll go back home and choose the second delay analysis application. Click here, and this is the way the input fields will be, and this is also in developers mode, so automatically when I click on the new row, the data will be generated, and based on this data, a final analysis can be done. A report will be generated. When I click the report generate button, report will be done, and we'll have a detailed analysis what sort of a delay cost are there. So we click on the new row. So these are the input data. These are different number of flights. We are taking a scenario where it's a historical data which has got a flight performance data of 7th July 2007. This is departure from New York to Chicago, and that is this particular JFK to ORD, departure from JFK to ORD. And these are the flight numbers. These are the tail numbers. So this particular airport, departure airport, this were the flights available which took off from here, and the equipment number, this is B744, that is Boeing 744, then CRJ1, then there is Boeing 4, then Embraer 145, then Airbus 320, and MD-11 also there. So this number of flights who took off from 7th of July 2007, and we will see the analysis. What were the delays? This gate delays were, this 389 is in minutes. So gate delay is in minutes. The taxi delay is in minutes. The air delay is in minutes. So this were the delays, and the number of seats available in the aircraft was 416, whereas the aircraft type was aircraft which was carrying was a 300 and that is a 325 seater. It could be the internal configuration of the aircraft, and then there are 50 seater aircrafts, there are 325 seater carrying 400, having the seat capacity of 416. There are 175 seater is there, 100 seater, 175 seater, and 175 seater and 325 seater. This were the flights being flown. Now looking at this other parameters is the crew. This is the in dollars, and the crew cost was $37 per minute. The delay cost which cost the airline $37 per minute. For taxi fuel, it was $5.79 per minute, and for fuel it was $116 per minute. This is the block time, which was the time the aircraft was in flying. So this is the in minutes for 144, 143, 140, 157 minutes which were there for flying. And then we have is the coefficients for the crew cost. Now there are calculations here which will be used for gate delay less than or equal to 15 minutes for the crew. The coefficient is 0.03. For greater than or equal to 65 minutes, the coefficient is 0.746. What are the other costs which are there in minutes? These are dollars. So 0.21 is the other cost associated with these delays, that is the gate delay. Similarly, for taxi delay, 0, less than 15, greater than 65, 0.43, and other cost associated with taxi delay is $0.1 per minute. So air delay is 0.01, less than 15, and greater than 65 is for 0.76, and 0.10 is the other cost for the air delay. And this is the crew coefficient for the crew. This delays costing, and this is for the other cost. So this is the input data we are putting it. Now we will come to know what are the what is the cost for the gate delay, for the taxi delay, and for the gate delay, taxi delay, and the air delay. So what we'll do is generate a report for this, and we can have the all this particular analysis of the cost. So we'll just have delay, and we'll click save. So it is saved the same place where this particular airfare Excel was there and the other exe was there. So we click on the delay, and we'll open the file, and we'll see how it is calculated. So this was inputted by us, this particular data out here via this screen, which is yellow highlighted, and now we'll have a look how it is calculated, how the costs are calculated. So this is for the New York to Chicago market on the 7th of July 2007. So this is what we went through, this particular thing of all the input data. Now we'll see what are the calculations. So you just see the maintenance cost is calculated automatically. It takes half the cost from here, and similarly if you look at $9, so which is the crew cost per minute, the maintenance cost is 5. So this is the way the assumptions have been taken. Now we'll look at the gate delay, how the gate delay is calculated. Gate delay cost is the other cost what we saw. The other cost we saw was what we saw was the crew coefficient and all. The cost is not the associated with the gate delay, but it's taken into consideration as other. This is for the gate delay. It's 0.21. If you look at this particular, we'll just go here. So yeah, so we'll look at this particular parameters, the gate delay. So how gate delay is calculated is $0.21. The other cost is there, and the gate delay is calculated via formula of the coefficient of crew into crew cost plus the other cost. This is other cost, and then this is the 0.3. These are the crew coefficient. So it calculates by for this thing. It will take 0.03 as the crew coefficient. Then it will go to the crew cost. This is 37. We're just taking one example of this, and it will then have plus this particular $0.21. So similarly, it will also have the other, which is greater than, the delay is greater than or is equal to 65 for the gate delay we are looking at. So what is the crew coefficient is 0.46 into crew cost, that is this 37, and then plus $2.1 per minute. So this is the way gate delay calculation is done. We'll see the figure. This is the highest, I think, delay over 389 minutes of delay. But others you can see 30 minutes delay, or gate delay 28 minutes delay, 24 minutes, 41.7. Taxi delays are, we're just looking at the gate delay, then we look at the taxi delay. So this is, we are looking at it. So what was the cost for the gate delay? So it came up to 67,200 or 247. So this was the delay for the gate delay for this particular flight, which was carrying which was flown here, and this flight number, the tail number, the Boeing 744, that's a big aircraft. So this was the delay that caused them, the gate delay caused them. And what was the taxi delay? Now the taxi delay calculation is done similarly, but here we'll take into consideration the fuel also. First, when we look at took the gate delay, did not have the fuel parameter to be calculated. It was just the crew cost and the coefficient of crew and the other cost. For taxi delay, the other cost is $0.12 per minute, and and the calculation is done like for the coefficient of fuel and into taxi burn rate, taxi fuel, taxi burn rate into the fuel price, plus the crew coefficient of crew and coefficient of crew into crew cost into plus this particular $0.12. So what with this calculation, the coefficient of fuel is calculated as 1 out here, and that is for under 15 seconds we are talking about. First we'll take a look at the 15 seconds taxi delay. 1 into taxi burn rate into fuel price plus crew coefficient, that is 0.0, and to crew cost plus crew cost here is this we're taking the first example. So this and plus $0.12. So that is the taxi delay, and so taxi delay comes to 100 and this is 1944 was the taxi delay. And let's have a look at the taxi delay. Is 23 minutes, 52 minutes for the other aircrafts we is looking at. Other aircrafts which are from 28, 20 and so and so forth. So this was the taxi delay part of calculation. Now let's look at the air delay, which was 10 minutes, 4 minutes, 7 minutes, and so on and so forth. We are looking at the first example, so we'll look at the air delay out here. So air delay, we'll go back and look at the coefficients. Air delay 0.01 for the crew coefficient, 0.046, 0.46 for the greater than 65 minutes, and the other cost is 0.14. Here also the same formula is used where the air delay is equal to the coefficient of the fuel. Coefficient of the fuel is taken as 1, and then it will multiply with the burn rate, and then the fuel burn rate, and then the fuel, and then it will have the crew coefficient of 0.01, and then the crew cost, which was $37 per minute, and 0.10 as additional other cost. So this is the way it is calculated, and we'll look into the air delay figure. That is, the air delay cost was 11,647 that was a cost 11,647, and when you have this particular air delay, we just took the first aircraft size, that was Boeing 744. It had a long gate, it had a very a long delay in the from the gate to fly, and then we had taxi delay, and the whole thing came up to $80,616 as the total cost of all the delays for this particular aircraft type on this particular day of 7 July 2007. So this is the way gate delay, taxi delay, and air delay is done. The same way with all the other aircrafts which flew on that particular day, all the other aircraft with other aircraft manufacturers, Embraer, Airbus, and CRJ. So this was the calculation. In all, when you look at the total delay, gate delay for the particular day was something like 69,976. This was 8,000. Taxi delay was 8,829, and there it was something like 31,589. And the total delay cost for that particular day, including gate delay, taxi delay, air delay, with taking in consideration all the other aircrafts which flew on 7th of July 2007, was this, that is $110,367. Now the other thing we can do here is also in this application is to look at which aircraft size had the maximum delays from the gate delays or taxi delays or the air delays. Which aircraft size, 50-seater, 100-seater, 175-seater, or 375. So some of the gate delay was maximum, that was done by a 325-seater, which we saw the first example from, that is Boeing 744, we took the example in this demo, which had the maximum cost of the delay, that was $67,117. And if you look at the taxi delay, which aircraft size was the maximum is $3,420 was for the 50-seater. That was the highest in this particular taxi delays for the aircraft size 50-seater. And then we look at some of the air delays. That was this is the highest, that is 22,129. That is for the 325-seater, and that is also the same what we saw of the aircraft Boeing 747. So in all, this is the different aircraft size which had the maximum number of delays, gate wise, taxi wise, and air delays. And then we have the final figures for 50-seater. What was the total delay? That was 7,974. This was for 100-seater. The total delay for that day was 6,764, and then the other one is 4,000. This is for 4,238 for the 175 seater, and this is 92,077 delay for the 325 seater. If you take other 325 seaters were also like if you look at it, so it was not just the first one which saw. That is a total of all the 325 seaters Boeing 744 had. So we can look here. So it was not just the first aircraft of Boeing 744. There was a year also Boeing 744 was there. So this is the way the application works, and it gives an insight of how the delay can be calculated and what it costs the airline for the delay. So this is the second application of this particular tool, and that's about it, which would be very handy for the airlines, both this application, airfare analysis and delay analysis. And thanks for watching.